Okay, let's go ahead and look how we can use our technology to do an ANOVA test. So what I've done here is I have the data set we just did by hand in the previous video in a Google Sheet. And I just typed the titles of each one and I just typed the data into columns. So what I want to do is I'm going to go to add-ons. Now, what we're going to use is this XL Miner tool pack. If you do not have it, you just need to go down to Get Add-ons, and it will take you to a whole list of add-ons that you can get. And you can just type in XL and it should come up with Miner tool pack. And then you can just click on it and add it. Mine's already installed, but it'll say install here where mine says uninstall. I don't want to uninstall it because I'm going to use it. So when I go to add-ons and I go to this XL Miner tool pack and I hit start, I just going to kind of show you what it gives you when you run this. So our ANOVA is a single factor, so it's this very first choice. So if I click ANOVA single factor, it asks me a couple things. First thing I'm going to do is it says input range. I am going to put all my data in there. So I'm going to highlight all my data, including my numbers and titles, and I'm just going to click there. And so basically that tells the computer what data I'm looking at. So I'll click labels in the first row. My alpha is 0.05. If it was something different, you could put there. Output range just is where do you want your results to go. I'm just going to click right below there and click in there. So A10. So when I hit OK, it gives me a whole bunch of stuff. So you can see here, it gives me, first of all, up here a summary, gives me each group, tells me how many are in it, the sum of all the data, and then its average, its mean, and its variance. So these are very important, obviously, because this is what we used to find our between group and within group variance to find the F-stat. Also what you see down here, some interesting things. I see the degrees of freedom of the numerator and denominator. But more importantly, there are MS, like I told you, the between group variance and within group variance, it shows you that. But the coolest thing it gives you are these last three numbers. So that would be our F value, 5.92, our F critical value, 3.68. So remember we said if F was bigger than F critical, we would reject. It also gives you the p-value. And just remember, if the p-value is less than alpha, we reject. And that's true for all significance tests. So this is definitely less than 0.05, so we would reject the null, just like we did by hand. So the technology gives you some really, really neat stuff, and it gives you a really concise way to put your stuff in. Then when you're typing it into a research paper or things like that, you can take the values you need and kind of ignore the rest, put them in there, explain what your result is. We can look at this second one as well. We can look at this one. This one, if I go back to the notes, is talking about the amount spent in dollars on energy in 1 year for a random sample of household in 4 regions of the U.S. It says that alpha equals 0.01. Can you reject the claim that the mean amounts spent are equal for all 4 regions? So if I wanted to write my null and alternative, just a quick recap, the way I do it on Google Docs is I'll go to Insert Equation. Not the only way to do this, of course. And then I can go H, and then there's a subscript button here, right here. H sub 0. And then I'll just, so I have H sub 0. And then I have a mu symbol, which is under this first one. So mu is right here. And then I can do mu sub 1 equal mu sub 2 equals mu sub 3. So it's just like the difference of mean one, except for I have one extra one. But you can have as many groups as you want. A lot of research studies will have definitely more than 3. Then we'll go down here. And we'll go to Insert. And we'll go to H sub A. And this was just going to say at least one pair of means is different. So there's my hypotheses for this one. And, well, actually, there are 4 in here, aren't there? So I should probably put a 4th one here. So equals mu sub 4. So we're going to try to see if I can reject the fact that they're all the same and then thus claiming at least one pair is different in this study. So we're going to do it all with the technology. So again, I have all my data plugged in here. So I'm going to go to my add-ons, my Excel Miner tool pack. I'm going to go to my ANOVA single factor. I'm just going to highlight all the data, and some of them are unequal in this case. That's okay. Just highlight the blank ones too. Click over there. I do have labels in my first row. Remember that it was 0.01 for our alpha in this problem. Output range, you can pick wherever you want. I'm going to pick right here. So it's going to put my results here in cell A15. So some important things that you should probably list when you're doing problems like this. You should talk about obviously the descriptive statistics you see here. These are all very important. And then down here, these 3 values obviously also need to be included in the chart. So in this case, you can see the F value is smaller than the F critical. That means we would fail to reject. You can also see here the p-value is much bigger than the 0.01, so we'd also fail to reject. So we can say since F is smaller than F critical, we fail to reject. Or you could say since P is greater than alpha, which is 0.01, we fail to reject. You don't really need to put both of these for a problem. Just one would be sufficient because they're saying the same thing. So our conclusion for this problem, since we have that, we would say there is not evidence to show that at least one pair of regions is significantly different. In their energy spending. I can spell tonight. So obviously doing this with the technology makes it much, much simpler. So go ahead and try that when you're doing your studies. Use the technology, type it in, see what you get.